Hi everyone, I'm Lior and I'm an architect with Informatica Cloud Platform. Do you guys hear me? Good? Great, channel number 2. That's good. I think the most common question I got about today's lecture is how do I pronounce your name? So it's Lior. I hope we got that finished. So I want to walk with you through how we do incident management and how we actually been transforming our cloud services from a monolith to a microservices architecture. Some few words about Informatica. So Informatica is the enterprise cloud data management company, which means we built data platforms, including data integration platform as a service, big data management, data quality, a lot of tools that help large enterprises to make more of their data. And that comes with different hybrid deployments with cloud, big data, traditional, and real time. Now, we've been around for 25 years, and we are the leader in 5 Gartner Magic Quadrants. And I'm going to talk mainly about the right part of the screen. This is the enterprise integration platform as a service, where we have been innovating a lot in the last 2 years, and basically wanted to make this kind of product. So our intelligent platform as a service allows organization to take data from whatever it is, from any source, and transform it, move it to any target. Okay, basically helping any kind of users, whether it's business users, analytics, data integration developers, to move data around to allow flexible deployments. Okay, now in Informatica we have around 4,000 employees. We are around 7 different geographies. Okay, and this is what we've been working for since we went through a cloud transformation. So we wanted to be a cloud-first company 2 years ago, and that become our target to make more of our products to onboard to our cloud platform. Which means is a lot of our products, since we exist for 25 years, were on-premise, and they got more and more attraction to the as-a-service deployment, of course. And we saw a lot of growth for all of our cloud services, many more transactions, data is being multiplied every 6 months. Basically, we understand we need to change something. Okay, and this is the deployment we used to have, where there's a big monolith doing almost everything, all the users' interactions, all the user management, logging, import, export, all of that stuff. It was just one monolith deployed in 3 different deployments. And every time we wanted to onboard a new product, it was very hard. They needed the different user management. They needed different privileges. It was very hard for us to move as fast as we want. And especially for all the statistics that we saw, we needed to accelerate our growth. Now, more than that, we also wanted to allow a unified behavior. And it was very hard to do when there is a big monolith that combines all those different features. So also, we didn't want to allow different products to make different security assumptions. And how can we, as a platform inside of Informatica, gives the best security and compliance that we can to have a unified behavior about that too. Now, we were very happy, and it took us around 18 months, I think, to build that microservice architecture. When you can see the clouds there, it's actually the different products that use the same core set of microservices. So the top bottom is the platform services, goes with user management and scheduling and all that stuff, the good stuff that you get from a core set of platform microservices. Okay, and different kind of products, like the integration cloud, data quality cloud, master data management cloud, are all using the same core set of services. Now that's great, and we were very happy. But as we said before, we have 85 companies of the Fortune 100, and they're already using our tools. How can we deploy that and really know we are not breaking anything? You know, they really care about uptime, and they're dependent on their data pipelines as the most critical, system-critical pipelines that they have for us to be up. So it's very sensitive. And we didn't want to just make a big bang, upgrade everything, and to be on that new wonderful world, which we know anything about how it really behaves in production. So we took that approach of having a different deployment and just migrating customers slowly. Okay? It was a very key feature for us to have a great monitoring platform to understand what's going on in the new system. And of course, new system, it's a new components to monitor, new kind of problems, probably much more because you have much more processes, much more hosts, cloud-first platform. Now, in Informatica, we really, as the guy from the MLB talked in the keynote, we really try to adopt as many types of users to standardize on that Sumo platform that global customer support, platform developers, application developers all look on the same data and be able to share their data. So it's a very fundamental emails exchange, tickets exchange. They always have a lot of Sumo queries attached. And even with a very little training, people are really using that democratization of the data to get more. Okay, people that can search for the configuration themselves, customer service that can look on all the interaction that a specific user did. Okay, it has much more context, and once you democratize this data, people get innovation from places you didn't expect, which was very cool for us. We have dozens of users that actively is using this per day. I think it's around a couple hundreds of users that use the system, but every day we're seeing heavily usage, okay, of all those personas. And we know it was very easy to add more personas and different product teams. As we explained before, there's the platform, there's different products, and to be able to share different view of the data for each one of them. Okay, so we have role-based access control. That works great. Now, we really wanted to have that polyglot approach of different data types, right? Because different products can have different data types, different logs, different systems that they use. As long as they can have the same log structure, or at least we can correlate the same requests and sessions, that will work for us. So that was good too. And as far as volume goes, we grow from 100 gigabytes to 1 terabyte without even knowing, which is good for us, bad for our accountant, but depends who you ask. It was very seamless for us. We didn't really need to consider the amount of logs and the amount of metrics that we push. We could just make it happen, and we trusted on Sumo to do so, and we actually never had a problem. Now, very key to that organizational impact is to know what we want to communicate on. We want to communicate based on data, and it's very important to treat logs as the first-class citizens there. So every developer really needs to think about what happens when people that are not that service developer reads those logs, gets those exceptions. That's a very fundamental part that a GCS that doesn't know anything about that can really understand what's going on. Search all errors for that user, you'll get something out of it. And not just for different customer support, but also for other products that integrate with that core set of features. You know, it's across geographies, so if somebody has an error just getting, hey, this is 500, it's not enough. You really need to enable them to know more and try to, at least the most common problems, to be able to search and act upon the logs that they are seeing. Now, three key use cases we use at Informatica is the troubleshooting, both it's a customer impact, a specific bug, or is it an incident when we try to analyze the blast radius, which we are going to talk a lot about in the coming slides. Some predefined dashboards that allow users which are not super user just to get a very good sample of how to start the troubleshooting from. Okay, we use a lot of that dashboard as a sample. It doesn't necessarily need to be the dashboard that everybody looks on, but it's a very good starting point, okay, to get to a specific service, to the specific deployment. Okay, just to have something in place helps non-proficient users to start at that. And of course, minimize the time it takes to resolve an incident, right? That's a very key feature in incidents. Now, alerting, we really like the alerting in Sumo, basically because it allows more people to create alerts. You don't need to be an expert on all services. You don't need to ask operations, hey, go create this alert. And you can just create alert, maybe even not for alerting code red and get somebody to wake up, but you can give alerts to give to this service owner, to that service specific, to get some more information about what's going on. Okay, so every incident that happens, we always end up having at least one alert to be a good signal that something is going on. And also we use it for feature usage to understand which API is being used, what's the latency, how this is behaving. Okay, that's kind of fun. Now, prerequisite in the microservices logs, I'm sure most of you guys know that, but the context is very crucial, right? You need to have that request ID to tie all the logs together. You need to have that session ID, preferably also usernames and user IDs, like the most common IDs that even not proficient user can use. Just put a simple search query and get which service, which are the errors that you commonly see. Very important. That's just a sample for an important endpoint that says, okay, this user, that's what the request ID. That's the tenant ID, the org ID. That's for us. Okay? Very crucial point. Now, I said before, every service that we deploy have, not using the new template-based approach that they use, but we just have a lot of dashboards that have that same graphs around. And the important thing is, again, different people that are not super familiar with what is going on can just look on the dashboard and either start that as the search query to refine what is going on, or to get a very even weak signals out of those dashboards. And we saw that before in some other lectures, but the percent of 95, the response time, the host distribution, many problems are you can pick up from host distribution getting quirked, response code ratio, CPU, and memory. And that's kind of the most basic that we want every service to have. Okay, that's how our war room looks like in Informatica Cloud. It's either that, people working on incidents, or watching the World Cup. It has two very important roles. Which is good. We have something like 12 monitors there, and everybody tries to share as much as the Sumo dashboard, Sumo queries that they see. And that's where we manage most of the incidents. Okay, now in Informatica, we actually got some training from a company called BlackRock, which are firefighters, past firefighters, that have a very nice process of incident commander and how incident management for operations with a great analogy from the firefighters department. Okay, so they led a lot of firefighting activities back in the day, and they now took their process of how the assemble looks like, which bridge is opening up, how to call the subject matter experts, all of that process. Very cool to get that analogy. And I think this is great because as in incidents, we are the firefighters. We are going to be the first responders. We always have that process to guide us, and we need to know what to focus on. And when firefighters are arriving to the scene, they're not trying to comforting the victims, which is important, but it's not what they do. They fight the fire, okay? So that's what they need to do. Now, we're fighting the fire. We usually not trying to handle with those angry guys, both if it's customers or product management, sales guys saying, oh, you just did something really wrong, and that's very important, not today. That's life, okay? This is very important. It's just not our job as first responders to handle that, okay? That's why usually we have two different bridges. One is for the technical bridge, trying to solve the problems, and the other is the guys that handle the angry people. Okay? The gate statuses, they know it's very important for us to update. We will show that in a second, but that's not our primary job. We don't want to handle with that. So that's how an incident workflow looks like in Informatica. It either starts with proactively getting an alert from Sumo, from other alerting system. Login is being slow, a node is being crashed, some functionality, or that our global customer support is getting few customers complaining about the same problem. Okay? Now, the first thing we do is we open an Atlassian Jira ticket that handles the dispatchment and the communication, the broad communication. So there's a few people that you really need to get into the war room, and also there's people that just need to know if they want to know more. They can just log into the Jira ticket and see what's going on there. Okay, that's the logging system. It's very important to have a scribe to log whatever happens, whatever you did. You restart something, you tried something, you got a good Sumo query, put it there in that scribe system to know what's going on. So other people that join later can see the same activity that went on. Okay. Now, that starts the war room assembly, and while operations are running the playbook, so they have that common playbook, restarting, trying to understand the blast radius. We'll talk about blast radius in a second, and do that common playbook. Sometimes it helps, sometimes it doesn't. And then we can either escalate to the L2 developers group to get more people, more hands-on. And basically, we're just trying to fix as fast as possible. And so again, it's an incident, it's a fire. We're trying to put off the fire and trying to analyze why it happened later. Okay? If all hell breaks loose and we cannot do anything about it, we have a DR with a specific SLA, so we can only do DR after 2 hours. That's kind of workflow. Now, it's very important for us to really be transparent and try to update our status site all the time, as fast as we can. Usually, you'll see there as soon as we know, we'll let our customers know. And as soon as we know what's the blast radius, who is impacted, we're trying to be as fine-grained as we can. And that's a key part of our process. So we don't just update that 2 hours later, we're trying to be very clear about that. Okay. Now, the most important part when you're reaching an incident is trying to analyze the blast radius. What's going on? Because that's what people will be asking, what's going on? You want to notify the customers too, and that's the first step to resolve the issue. Okay, so first thing, where is it? What's going on? Who is impacted? And remember, we are a platform, we have different products. Different products are affected by different types of incidents. So first, we're trying to understand, is it global? nobody can log in? Or is it a pod, a cluster specific? We have 7 clusters around the world. So is it specific to a login to a specific cluster? Okay? And that we usually use the field extraction. And again, if somebody is not using it to the full extent, it's a shame. Really use the field browser statistics so people can just watch on the field pod, cluster, number of hosts, all of that to see some very good insights right over. Okay? And also have that predefined dashboards for the scope. So you have a dashboard per pod. You can, and we'll see an example for those things, but I'll just articulate what we are going to see is just, is it a pod related? Is it a host related? Is it a service related? So having different dashboards with different aspects can be really helpful. Okay? Now we really try to have this indicative endpoints to know when it started, because one of the most important things is to know when the incident really started and when it ended. We'll show that. And actively post in the war room, right? So other people can contribute. Not everybody in the war room just there in the first 5 minutes. Maybe this, you don't, when the incident starts, you don't really know how long it will be, right? So you think it's going to be short. You don't know, maybe it takes 3 hours and a lot of people from different time zones will join. So really keep that scribing up. Now I'm going to walk us through a critical endpoint that we have and many incidents that we have with that. A very critical functionally is just running a data integration job, which means that's what people do. We are running data integration jobs. So you should see a lot of traffic here, okay? So if that doesn't work, basically nobody can run integration job on our service, which means we're down. Okay, so as we said, it's a very nice start to start with a response time by pod. Okay, so then you will get some kind of idea if there is something specific to a pod and have a better insight. Because again, even if you didn't get it proactively, but somebody called saying, hey, there's a problem logging in maybe. Even if the problem is in login, sometimes you can really get some information from the indicative endpoints. Okay, I really think that you should take 1 to 3 critical endpoints and try to see the incidents through them. You will always get to the actual problem later, but to get a severity 1 level incident, very important to have those critical endpoints. Okay, in this example, you can see there most of the pods are acting right, kind of in the standard deviation, but one is really acting up, have a very large response time, and then nothing. Seems like something is going on. Okay, we don't know what, but we know where to look, at least. Okay, when we have multiple deployments, it's very important to have some start. Now, so we drill down into some pod, and then you can just see, is it a host specific? Maybe there's something specific in that host. Those things really should pop up. Most standard problems comes with a specific host. And then later on, you can look on the metrics. You know, there's a lot of other things you can see, but at least to get that scoping, right? Pod, host. An interesting problem that we had is that's part of the indicative part, right? So we had a problem which had nothing to do with that job API. It's a different service altogether, actually even different deployment in the world, but we got no traffic for a specific time frame. So you really can know when the incident started. Nobody can log in, nobody can log in, nobody can run a data integration job. So it's not a problem itself, but it's really indicative where to start, when to start, where to look for. Okay, that was a very interesting. So no traffic, also bad. Okay, and that's, so actually Brian was talking before about making metrics out of those things and how to alert if there is no traffic coming on. That can be very beneficial in those cases. Okay, the other side of that, when you're really starting to see response time fluctuation, and again, this was actually impacted from other services. What happened? I lost my slides. Okay, back. So you're seeing that fluctuation, and actually another service was using the resources. So you can see the response time is being impacted, so you do get alerted. But the worst part, you will still get it functional until that top line at the end, when you're reaching the maximum. Okay, so when you line up, it's pretty much like a person on a heart rate, it's getting flat line. That's kind of how it is. So at least you can see whatever, when it started, when it ended, and what were the impacts, right? Blast radius. So there was some service interference doing that fluctuation, but the service totally died when it got flatlined. Okay, now another good indication is the API distribution across hosts. Okay? Many times you can just see if there is a traffic, if there's a specific load coming to a specific deployment, just by looking on API distribution. Okay? You can look on specific API, like the job API that we look for, or across APIs. Usually it's good to get some kind of fluctuation there. And then you'll be able to see, again, indication. Is there a problem? Do we see a problem? Where did it came from? Where does it go to? Now, alerting. So we could take all of those incidents that we have, and again, making an alert out of every incident. And we have a long list here, but basically, even if you have either step 1, step 2, whatever happens, if you democratize the alerting and you really engage people how to create those alerts, even to wake somebody up, it's really crucial, right? So we had a mail server problem. So we just have a very simple, specific exception alerting, and if that happens, we alert. Okay, we have timeouts both in the client and the server of database. You have HAProxy problems. So all of that really easily become alerts. Okay. Some other examples, other source types. So we have metrics from RDS that we pull. And actually, after we migrate, remember that migration? After we migrate a few heavy customers, we were starting to see very high spikes. Every hour, we were getting 80% utilization. And we were not sure why. And we're not sure even why every hour. And it turns out that those heavy load customers really used most of their data integration jobs were running every hour, which was both interesting usage-wise, but that's how it is. So it turns out that people don't just schedule for midnight to run integration jobs, but they run it every hour. And that actually became a very trafficked endpoint. And we could correlate that against logs, right? So that's what you usually see. You see the metrics getting 80%, and we were able to correlate that with a specific service and just the number of times it was queried. There's nothing wrong with the service. It's just in that microservice environment, of course, there's a few other services using this service. But the correlation between the time that it takes, you can really see what is going on, and we could improve that endpoint to make it a lot less heavyweight, to cache a bit. But as soon as you have the problem, it's very easy to find the solution. It was hard to see where does the problem comes from. HAProxy. So one of the new components in that new platform was HAProxy. We did not manage the load balancer before, in the old platform. And so it was all new to us. And the good thing in kind of systems like Sumo, that you don't need to know everything up front. So we didn't know. We have a very basic, is the host up and running, memory, CPU, all those things, which never find anything. So that's good. And one day, we just took one of the HAProxies down. We thought that the CPU usage utilization was very low, as we could look from the CPU and memory. And once we took it down, after an hour or so, we were starting to getting reports on slow logins, something is going on, and we had no idea why. We were looking on the tomcat access logs. Everything looks fine there. Things were getting very fast. And only when we graphed some new metrics that we got from HAProxy, because again, the data was there in Sumo. We log everything. We just didn't really understand what we need to watch. And once we understand that metric that actually just say the max active connections, we could see, only after we graphed it, we could see that we are flatlining somewhere. We are seeing actually, we flatline at 2,000, which we didn't know why. And after just going back to it, we understand there is some active connection limit that we hit. It was only because of that graphing. So we just added back, and you see afterwards it became great again. That was interesting. Very interesting point. So, but the point is, you don't really need to know everything up front. And of course, since then, we are monitoring it very carefully. It become a very important KPI, but you can grow as you go. Now, another new component was Kafka for us, and we were not great in making it very operational. We could see problems, so we were monitoring from either client side, if there is any exceptions, either in the client side, like JMX for the latency takes, and what we got from it is actually, it was a good monitoring, but we didn't get to the actual lag inside of Kafka. So we had a few occasions when we migrated a lot of users, and then things started to be slow. We are using Kafka for the logs consumption, so people were not able to see logs very fast. And once we just took a few more metrics from Kafka, then we could just having alerts on the lag itself. Okay, so just basically getting the queue size. If it's more than X, we can alert on that. And that's, again, a very indicative point, because you do expect it to have some kind of a lag. not this large as we see here, but we can use it as the same as the metric we explained before, right? If there's nothing, hey, that's bad. Nothing is running. No logs are coming. It's a bad thing. More than a specific, not good too. So it's a good indicative point as well. Now, not in a security use case, like sometimes in Sumo you will see detection trying to understand is this IP is malicious or not. We have actually kind of a different use case. Sometimes one of our customers that we have a lot of APIs is using the APIs wrongly or massively, or he's got some issue with his side doing a lot of retries and all that. So that's actually very helpful for us just to visualize who's the IP who's calling us, to find out a few very crucial endpoint, a few crucial problems that we can just call them or stop them or unlicense them and continue. Okay? So some key takeaways. Moving to a microservices architecture forces a lot more monitoring and troubleshooting, right? Because in the old days, you could really pretty much have that operations, take the log when you need to, run a script, get something. That's, of course, no longer the case. And democratizing the logs and democratizing the actual data inside is very important and get a lot more innovation out of it. Very important to establish a process for incident response. People act the best when they know what is expected for, and to be that first responders, have a process. Those black rock guys are really interesting concept. And communicate based on data. Once you make that data, you don't believe anymore to theories, right? You want to see that correlation. You want to see that every incident, you want to see the correlation between when it started to when it ended, those critical endpoints that we described. It's a key measurement. That's it. Thank you.
Okay, thank you so much, Lior. Any questions?
Hey, was one thing you mentioned towards like the last third of your presentation was it wasn't that you didn't have the data, right? You logged everything. It was not knowing what to look for, or maybe not knowing the value of what you had. Do you find that to be a recurring or common problem with other folks you talk to as well, or for yourselves for that matter? Are there new problems that you're finding solutions to because you had the data but you just didn't realize it?
Definitely yes. I think that continuously improving, and especially when you're bringing new components. If you have the same legacy system, you already know what to look for. But when you're taking those new things, new services always come with new surprises, and you really need to keep up improving this. And that's the pattern, right? Log everything, trying to see if you get any value from it later on. That's what it usually happens, right? So you really know where the key endpoints after you're seeing an incident, you see that those graphs during those incidents. That's how you really get. And the important thing is to learn, right? We all learn from this. We want to be better. That's the process.
Okay. Thank you so much, Lior.
Thank you. Thank you for.
Thank you, everybody, for attending.